So, my name is Shivsai. My topic is portfolio optimization using create decent algorithm. So, first of all, what is meant by portfolio optimization? It's a portfolio optimization which is to build your portfolio in such a way that you can maximize your returns from the investment uh, without any additional budget or without increasing your budget. So here the portfolio optimization problem is specified as a constraint utility maximization problem. So these are the few terms we often use in in our upcoming slides. So first one is the portfolio returns. Is technically we can speak that the portfolio return is the mean of the mean of the returns. So portfolio return can be defined as the sum of the product of the investment returns and on the individual asset with the weight of the class of the individual asset in the entire portfolio, means the total value of the portfolio. So they represent the portfolio return. The portfolio is the calculated, measured by the variance of the portfolio returns. So it tells us the risk at the each investment, or we can tell as the okay technically we can speak that portfolio risk is a variance. So risk aversion parameter is the tendency to avoid the risk. This parameter helps us to avoid it helps us to tendency to avoid the risk. So we will not discuss deep about these parameters. So what is the objective function of the portfolio optimization? So here the portfolio optimization has a different objective functions. The most basic form of the objective function for the portfolio optimization is the expected portfolio return plus risk aversion parameter into portfolio risk. So the most basic form of the objective function for the portfolio optimization is expected portfolio return plus this we already discussed. So the here the expected portfolio return is the mean of the expected return, as we discussed in the previous slides. The portfolio risk is measured by the variance of the portfolio returns. So there are the constraints in the portfolio optimization helps to ensure that resulting portfolio is feasible and consistent with the investor preferences. So there are a few some of the constraints, since like the budget constraint, asset allocation constraint, and the expected. So there are several ways to solve the portfolio optimization problems. So few of them are the mean variance optimization, minimum variance optimization, so meta-heuristic methods, and Markowitz mean absolute optimization, condition value at risk optimization, robustic optimization, integer optimization, stochastic programming for multi-stage portfolio optimization. Each method has its own advantages and disadvantages. It depends upon the investor choice which method they can use. So here we are using the one of the famous and popular method for the portfolio optimization, that is mean variance optimization method. It is developed by Harry Markowitz. This method suggests that the investor can build an optimal portfolio by selecting the assets with the highest returns and minimizing the risk. So let us understand how can we calculate the portfolio return and variance in the mean variance optimization method. So let us assume we made two investments. So first investment we will define as an maybe $100,000. We made an investment of $100,000 and an expected return of 5%, and then we made another investment of $300,000 and an expected return of 10%. So the total portfolio value amount mentioned as a $400,000. So the weight E, the investment weight E, means how much the percentage in this percentage of A in the portfolio is the investment A by the total portfolio value, gives the percentage of investment the total portfolio value, that makes it as a 25%. So similarly if we calculate for the B, it gives us 75%. So the portfolio return is the investment A weight into the expected return of investment A, so plus the investment B weight in the portfolio value into the expected return of the investment B. It gives 8.575% portfolio return. So how can we calculate the portfolio variance? So here the portfolio variance is equal to omega square a, sigma square a, omega square b, sigma square a. Here omega a is the return of the investment a, and omega square b is the omega square a is the omega square b is the investment of the b, so return of the b. So if we calculate that, we will get here rho ab is the correlation of a and b investments. So we correlation between the how they are dependent to each other. So if we calculate that portfolio variance, it's so we will what is the important and the significance of the portfolio variance we will discuss in the upcoming slides. So here the what is the gradient descent algorithms. So we'll discuss the gradient descent the goal of the gradient descent algorithm is to minimize the given function. So we can achieve this goal by assuming an initial weight. We'll guess an initial weight and we will calculate the gradient, the slope, and at the slope at the point we assume that point, and will move to direction in the opposite to the direction of the gradient, and we will slowly increment, and we will reach the minimum value of the function. So here the alpha we choose, it depends upon the alpha we choose. We will choose the alpha around in the order of 0.10 power minus 2. So it's the most important for us. So the flowchart of the gradient descent algorithm is, so we'll and assume some initial weight guess, and then we calculate the gradient slope of the gradient. Then next we'll change the gradient, or we'll scale and we'll assume the alpha, and then we compute. So we'll compute that values and we'll update the weight, and we'll do up to this up to maximum iterations, or up to threshold value. We'll choose up to between threshold value, and we will end this process. So what is our objective function? So here the objective function is this, and with respect to the constraint, the sum of the weight of the assets, all assets should be equal to 1. So here we follow the few steps to solve this problem. First we will import the data assets of the stocks, and then we define the weight constraints, and we define the objective function, and define objective function, and returns, and the portfolio variance. So and we calculate the gradient objective function, and then we will update the weight by taking a small step in the direction of the negative gradient, which means opposite to the gradient. So and we'll do 4-5, we'll repeat the 4-5 steps until we reach until a maximum number of iteration is reached, and we'll calculate the optimize the portfolio return and optimize risk, and we plot the graph between portfolio return versus portfolio graph, which means a frontier efficient, which we will discuss in later in upcoming slides. So here we solve for the three data assets. We solve the optimization for 3 data assets. So first I pick up the few stocks, 3 stocks: Google, NHPs, Comacast, Megas. So here the period is over 10 years. I took the average of the 10 years and calculated the return, and it given the result as 4.7.95% return over the 10 years period. NHP, it's a live stock market. I calculated this live value from the live using a Finance library. So we'll get these values. So next we'll calculate So the next step is we will define a portfolio return define the define the portfolio return function. The portfolio return function weight into return, which means mean. So next we will define portfolio variance, that is o, omega means weight of the transpose into c. Here c is a covariance matrix. Here omega w is the weight of the stocks. So next, so if we calculate that, we will get here initial weight. Here initial weight is a random weights, is a randomly generated weights, and for that we'll get the portfolio variance as this much, 0.013 and 0.0. Here this heat map is the covariance matrix. How this covariance matrix help us to determine, it helps us to determine which stock is risk and which stock is very risk and which stock is very low risk. So it significantly tells us over the time the investment could be risk if the return varies significantly over the time. So the investment could be risky. Generally the asset with the low variance of returns are less risky, but they can often provide a relatively smaller returns. So the covariance matrix is like this, and the diagonal elements of this matrix is the variance of the assets, means the variance of the assets which picked. The variance of the Google is 0.013, the variance of the HP is 0.02, and the variance of the Comcast is 0.01. So these are the, so you can see that HP and Google have the highest covariance matrix. So we can expect that these stocks are high risky stocks, but they give an high returns. So next we will define the objective function. The objective function is the portfolio return plus portfolio risk into risk aversion matter, and we'll define the gradient. We will calculate the gradient. So if we calculate the gradient, we will get weight plus 4 into risk gradient. So next we will update the weight. So we will choose first initially this weight, and then here the weight 1 is equal to weight 1. Weight means this indicates that we are equaling the weights, so the sum of the weights always equal with this line of this code. This line of this code explains that. So next, so after solving we get the weight. These are the initial weights because, and the portfolio return for the initial weights are 0.03, and the portfolio variance for the initial weights are 0.01. So here the next optimized weights are 0.013 and 0.47 and 0.0. If we calculate the portfolio return, it's the 0.39, and the portfolio variance is 0.609, and the 609. So if you plot the graph, so here the red dot indicates the optimized portfolio value, and initial dot explains the initial portfolio value. This blue dot explains the initial portfolio value. The graph is between the return versus risk. So initially the returns are this 0 point something, 0.35 something, it's around 0.35 something. Then after optimizing the weight, we get over 0.039, and with the almost the same risk. So next graph is the objective function versus number of iterations. So the objective function is increasing as the iterations are increasing. So how the weights of the each asset varying with the number of iterations. First this blue line indicates the Google, and the green indicates the Comcast. HP, this orange indicates HP. As we can see, the HP is increasing, and the Comcast Chromacast weight is decreased as the number of iterations is increased, and the Google Google asset is increased as the number of weight is increased as the number of iteration is increased. And then next is the efficient frontier. So as we discussed, the efficient frontier means the plot between the return versus variance. So this helps us to choose the stock. So choose the stock. Also, we will discuss much more deeply in upcoming slides. So if we do similarly for the 5 data assets, so I choose some or few additional stocks, and we get these are the covariant matrix, and these are the initial weights, and so these are the values for it. And initially weight are these, and the after we get optimized, after we solving we get this optimized weights. And so portfolio return is 0.03. After portfolio return is increased to almost 0.377, and so almost the portfolio variance is 0.03 and 0.0. So let us plot the graphs. So return versus risk. So initial portfolio value, this blue dot increase initial portfolio value, it is around 0.30. The optimized portfolio value is increased about 0.039. So but the risk is improved, the risk is very high. So then next, objective function versus the number of iteration. This is increasing as the number of iteration is increased. So weight of each asset versus number of, so these are these. So and this is the efficient frontier. So what is the drawbacks of using the gradient descent algorithm? So here the most commonly common problem is, so suppose if we we achieved the local minima, but it is not a global minimum. So we solve up to this, we'll get the value up to this, but it is not a optimized solution because we have the global minimum. So this is one of the problem. We can eradicate this situation using sophisticated gradient descent algorithm. Then one more problem is choosing the learning rate, the alpha. So the choice of the learning rate can greatly affect the convergence of this algorithm. If the learning rate is too small, the algorithm may converge slowly, and if the learning rate is too large, the algorithm may not converge well. So as a small learning rate, it requires many if we choose too small, we require many iterations. If we choose too high, then the function will jump drastically. So it means if we choose very high, then function can immediately move on this side, so we cannot obtain the minimum value. So we need to choose optimally, and we need to reach it, the minimum point of the. So lastly, we can see that the weight of distribution of the optimal returns are achieved when the majority of the portfolio is allocated to the asset with the highest returns expected. Conversely, the portfolio with the least risk will have a weight distribution primarily allocated to the asset with the lowest variance. In addition, by overlaying the efficient frontiers of these three portfolios, finding that low covariant variance asset to the portfolio achieves 2, there are more options for portfolio distribution with a lower risk. So there are more options for portfolio distribution with a lower risk. At the each increment of the expected return, the risk is reduced. Conversely, sometimes the increment of the risk is increased, but return is also increased. The number of assets increases. As the number of assets increases, you can see the portfolio return is decreasing. This is a limitation of the gradient descent algorithm. So how can we we can improve the gradient descent algorithm for maximizing the profit using the same mean variance optimization. So firstly, we need to choose the asset with the highest returns. So basically we need to choose the assets with the highest expected return, or we can adjust that risk aversion parameters. Thirdly, uh, we can thirdly we can use different algorithms. So there is a result showed that in the so we can use different algorithms to improve the ma- to improve the optimization or to maximize the returns. So these 10